Hey everyone, I hope you all are safe and doing good. So, in the series of learning C++ programming language, we are discussing 2D arrays. In the previous video, we have seen memory representation of 2D array and how to access elements from 2D array, right? Two technique for memory representation, row measure and column measure, right? And using index, just provide row index and column index and you can access elements, right? But what is happening behind the scene? Like when you say how the memory is to be allocated to those elements, means addressing of 2D array elements, how this is to be done, how the address is to be calculated, like which element is stored on which address, right? This is known as like addressing of elements. So this thing we'll see in this video, right? Addressing in 2D array. Okay, let's take that simple example first. Let's take this is a 2D array, 3 into 3 array, 3 column and 3 rows, number of rows, number of columns. So this is how I'm going to initialize this thing. First row, second row, third row, right? In first row only 2 elements I have given, in second row 3 elements, third row 3 elements, right? So if you visualize this thing, then how we are going to store in the form of like a matrix. First row 1 and 10. And the remaining element is by default 0, minus 1, 9, 5, 2, 70 and 22. This is 3 into 3 matrix, 3 rows and 3 columns, right? Number of rows, number of columns. Index we know by default start from 0, so 0, 1, 2. For column also 0, 1, 2. Index would start from 0, right? So this is the case. But how now the addressing is to be done? Suppose the base address is, memory manager has allocated base address is 100. We are taking simple address, right? We are just supposing that base address is 100. Actually it is in hexadecimal form, right? So how this is to be stored in memory? Like this. There are two memory representation, row measure and column measure. By default 2D arrays are stored in memory with row measure representation. So both the things, addressing in both the cases we will discuss. There are two formulas. So first we are checking row measure representation, right? So we are supposing this array has been stored in row measure ordering in memory. So first row, second row, third row, like this. So first all the element of first row, then second row, then all the element of third row. This is the case. And suppose base address is 100, right? So how now the address is to be calculated like for all the elements, like for minus 1. For minus 1, what should be the address? So like this, we know every element is taking 4 bytes, integer is taking 4 bytes. So for next element, it is 104, 108 and so on. So how many total bytes would be allocated? How many elements are there? Number of rows into number of columns, 3 into 3, that is 9. And one element, each element is taking 4 bytes in memory, into 4, that is 36 bytes would be allocated, right? But now how actually this addressing is to be done? There is a formula, how the address is to be calculated. Right, now let's take, we have example of this element 9. So index of this is, if I say A of first row number is 1 and column number is 1. So A11 will give you 9. First this row and this column, right? By default index is from 0 to 0. But how this address is to be calculated? The address of this 9 is 116, right? There is a formula. See, you know the base address, you know from where to start, from 100, right? So in base address, what you are going to add? Base address plus, suppose here we am taking I, J. For general formula we are calculating, right? Ith index, jth index, I for row, J for column. Base address plus, now what? How many bytes to be added? Like base address 100 plus we will add here 16 byte. So 100 plus 16, 116. So address of 9 would be, for 11 would be 116. But how this number of bytes would be calculated? See, obviously you will see first, we are in this row. So how many rows before this row? Our actual element is 9. So how many rows before this row? It is first row. So 1 row, right? So how many rows? This how to be calculated? I am taking example of A11. So this thing, this I will give the number of rows before the actual row, because our element, the actual row in which our element is, that is this row. So before this we have first one row. So this ith value will give this thing, right? If I take this example, a of 2 and 1. So how many elements from how many rows? Before this row 1, 2. From where we will get this idea how many rows? Obviously from the ith value, whatever we have given, the I value, right? So I, now into, in each row how many elements? In each row how many elements? Means how many columns? What it will, from where we will get this value? How many number of columns are there in your 2D array? And number of rows, number of columns. Suppose I am taking this value m and n. M is equal to 3, n is equal to 3. M means number of rows, n means number of columns, right? So I into how many number of columns in each, or how many number of elements in each row equal to how many, the number of columns. Number of columns we will take from this variable n. So I into n, right? Now plus, suppose I am taking this value a11, 9. So now we are in the actual row in which our element is. But before this element, how many elements are there? Before this element, how many elements in this row? From where we will get this value? Here before this we have one element. So from jth value, we will get this idea, right? Before this, how many elements we have? Only one. So on plus j. It's not into, right? It's plus j. Because if we take this, suppose this example 1 and 2. So number of rows only 1, right? So 4 byte for this, 4 byte for this, 4 byte for this, right? Now before this, how many elements? How many elements? That just we are going to add, not into, right? So plus j value is 2, so only 2 elements. So j value will give this idea, plus j. And whatever this thing, that number of bytes will add into base address. So this is the simple formula. Okay, there is something missing. Into, obviously into, you have to calculate number of bytes. These are the number of elements from the actual element. One element will take 4 bytes, or the, you can say, the size of that particular, one element in that particular array. So into size. These many number of bytes we are going to add in base address, and then we will get the actual address of that particular element. So this is the formula for row measure ordering to calculate address, right? If we take example of 1, 1, then base address suppose 100 plus I value is 1 into number of columns 3 plus j value is also 1 into size is 4 bytes. So this would be 16, it would be 116. And yeah, for A11 is 9, and for 9 address is 116, right? Actually this is not the complete formula, this is the basic one, right? The variation of this formula also I'll discuss with the help of one example. But first of all, for that, to understand that complex formula, you have to understand this formula. And why? It's not like that just, learn or just cram this formula. It's not like ratification, no, that kind of thing. You have to understand why we are doing I into n plus j. Why? Right? I hope you got this idea. If not, pause the video, just, rewind this, watch it again before going, for the second formula. So I hope you got this thing. Now, please calculate for this A, 2 and 1, and you can just check me on comment section. Now this is for row measure. Now let's suppose second is column measure. So in column measure, what? How to represent? Column wise. First column, second column, third column. So first column, so 1, -1, 2, 10, 9, 70, 0, 5 and 22. This is the case, right? So yeah, in this case addressing is something different. For 10, if you take here, for 10 the address is 112, but in row measure the address for 10 was 104, right? So now how this addressing is to be done? What is the formula in this case? If you got this formula, then it is very easy for you to get the second one for row measure. I and j, same in base address, what you are going to add? So if you are taking this example, suppose I'm taking this example this time, A of 2 and 1, second row, first column, right? Okay. For 70, it's 120, but how to calculate? In column measure for 70. So first in column measure, we know first column we are going to store first, then this column. So before this, how many elements are there? 5 elements. So how to know that thing? First, for this column, 70 is in this column, first column, like the column having index first. So before this, how many columns we have? Right? One column we have. But from where we will get this idea? From this thing, I and j, from j value. J is because column index, right? J is here 1, right? So before this we have only obviously one column. So this will give idea this thing. So here j into. Now j into how many elements in this column? Equal to obviously the number of rows. So number of rows we will get from m into m plus. Now in this particular column, we are in that specified column. How many elements before this element? 1, 2. From where we will get this idea? Whatever the index for row, 2, 2, right? So from before this we have 1, 2, 2 elements. So plus I into size. I hope you got this formula also. These are very simple. If you are not getting, please pause the video and watch it again before going to, the complex formula. Right, because it's very, important to understand these two basic formulas. Right, now if you calculate address of A21 in column measure, so 100 plus j value is 1 into m value is 3 plus I value is 2 into size is 4. So 100 plus, it's 120, right? So for 70 to 1, it's 120, right? And if suppose this is, we are supposing this has been stored in row measure. So in that case, A21, what should be the address? In row measure, this is the formula. I into n, I value is 2, 2 into n is 3 plus j value is 1 into 4 is equal to 100 plus, it is 128. So in row measure, for the same 2, 1, for 70 the address is 128, in column measure it's 120, right? I hope you are getting the difference and why are these kind of difference. Okay, so these are simple formula, but one type of problem you will get in university exam also, in competitive exam also, that is some kind of, that is different thing. Here by default the lower limit of row is 0, lower limit for column is 0. Index is starting from 0, right? We know. So that is why this is the simple formula. But if question is something like this, this is the thing. We are given an array and this kind of thing, 10 ... 30, 55 ... 75. Base address 1020, size 4 bytes for one element. You have to find out the address for this A15 and 68. Now, and the representation is row measure. What you will do? You simply put here something like this. Base address is this. I is 15, n is, and number of columns. How to calculate? Because A is something like this. Then size is given 4. So here the formula is something different. Here the case is lower limit for row is given 10 and upper limit 30. Means you can say the index, right? Lower limit, lower index of column is 55 and the last index for column is 75. Index is not started from 0 here. So the situation is something like that. So here this is the case. Index, the lower index for row is started from 10 to 30, 55 to 75. It's not from 0, 1, 2, 3, 4. No, there is something different. So how to calculate now m and n value, number of rows and number of columns. Number of rows m are 30 minus 10, obviously plus 1, right? So 21. You can calculate from 10 to 30, it would be 21, and n is 75 minus 55 and plus 1, right? So 21. Number of rows, number of columns are 21, 21, right? Okay. Now, formula is something different here. A of ij, if you want to calculate, here I value is 15, j value is 68. So, same base address would be same, obviously, plus. Now, this would be something different. Okay, it is row measure and 15th row, this row, and 68 column, somewhere here, 68 column, this, here is some element, addressing for this element, right? So, how many rows before this row? You have to calculate that according to the formula, which value will give that I value. But directly we cannot say I into n because I value is 15. But before this row, how many rows? 1, 2, 3, 4, 5. It's not 15 rows. Why so? Because the lower limit of index is 10. It's not 0. So only 5 rows. So how to calculate this thing? 15 minus 10, 5. So the formula is here. I minus the lower limit for row index. LR. Lower limit for row. Right? This. Not simply I. Into how many columns? Obviously, how many like elements in these each row equal to number of columns. So we'll do obviously into number of rows into in each row how many elements are there, right? To calculate all the elements into n, right? Okay, this is the case, but n how to calculate I have told you. Upper limit for this column minus lower limit plus 1, right? That would be n, right? Plus, here we have j, obviously. From this, before this, now in this particular row, we are now in this particular row. So, how many elements before this particular element? Plus, how to calculate? It's not like directly write down here j, 68 element. No, there are not 68 element before this element because index is from 55. So, how to calculate how many actual elements before this? J, whatever the j value, minus lower limit for the column. Lower limit for the column index means actually 68 minus 55. These many elements would be there before this element, right? So, j minus LC into size. So, in this case, this type of formula would be used. So, actually, if we say the complete formula for addressing is this one, right? In that formula, we are not using LR and LC lower limit because lower limit is a 0. So, it doesn't make any difference. But if this is the case, then you have to put these lower limits, right? So, if you find out A15 and A68, then base address 1020 plus. Now, I is 15. 15 minus lower limit is n. Into n, we have already calculated it's 21 plus. J value is 68 minus lower limit for column is 55. Into size given 4 bytes. I think it will give you 1492. You just calculate this thing. Maybe there would be a calculation error. I hope you got the formula. This is in row measure. But the same thing is, suppose I have given, in formula it is given, the representation is column measure and you have to find out 15 to 68. Then you please pause the video and just write down this formula, find out this formula, right? In this case, for column measure representation, right? And just write down in comment section. Yes, you got it yourself. Without watching this video, you can just comment this thing also. Now, see, obviously the base address plus for column measure, if this is the case, if you are representing this in column measure, so from before this element, how many elements, how to calculate? Because first we will store this column, then second, then third, fourth, like this. So, how many column before this, how to calculate? Whatever the j value is given, j minus lower limit, right? How many columns before this? 68 minus 55, right? Now, into in each column, how many elements we have? Though that would be equal to number of rows. So, how to calculate number of rows? 30 minus 10 plus 1, that is 21. So, directly I am writing m here, right? Number of rows. But there is different formula to calculate number of rows and number of columns that I have told you, right? Plus now. How many elements before this particular element in this column? That thing, what will give that thing? I mean, this I, so it's I minus lower limit of index, this index. So 15 minus 10, that is, obviously before this element, actually in this column there are only 5 elements, right? So 15 minus 10 is, it would be 5 into size. So I guess you got it. Now you can just put the values of these values and you can find out the address, right? That would be something different. Like 1020 plus j value is 68, 68 minus lower limit for column is 55, 55 into 21 number of rows we have already calculated. I is 15 minus lower limit for I is 10 into 4. So if you calculate this thing, that would be something different and it would be something 2132, I guess. If I'm wrong, you can just let me know in the comment section. So I hope you got the formula. So actually the complete formula for row measure, column measure to calculate addresses, these formulas, right? But in these cases, but by default if the index is 0, 0, then we simply ignore LC, LR and these things. We simply put these formulas, right? So I hope you got these formulas. If you are still confused, then in next video we will see 2 or 3 more example of addressing, right? So now I'll see you in the next video. Then bye bye. Take care.